Hello everyone, welcome back. Today we're going to be solving next grader element 1 and 2. These are monotonic stack problems. We're going to be solving both to really dig in and make sure that we understand the strategy and how it can be used to find the next element in an array that satisfies some constraint. So to get into the problem here, next greater element 1, the next greater element of some element x in an array is the first greater element that is to the right of x in the same array. You're given two distinct zero-indexed arrays in this case, nums1 and nums2. Basically, the goal is to find the number that is greater than the number that is at the current index in nums2, right? So the goal is basically step through nums2, and for each element that is in nums1, which is a subset of nums2, find the next greater element. So for 4, it doesn't have an extra element. For 1, the next greater element is 3. And for 2, it does not have a next greater element as well because it's at the end of the list, right? And so that's how you get this output array of -1, 3, and -1, right? Because if we cannot have an next greater element, then the proper answer in that case is -1. So we're going to use an XCaliDraw to kind of explain this. So and the brute force solution here would be to use a double nested for loop, basically iterate over the range of the length of nums from 0 up to the length, get the value at the index, and then basically iterate from that the next element after, or the next index right after I. And when you find the next greater element, sort it in some dictionary to say, okay, the next greater value for 1 in this case would be 4, or then 3. And so, and then at the end, you would just return the values for each of the keys that are in nums1, right? And so that would be a exponential solution. It would be n squared time complexity because we're doing at least one iteration over the entire array for each element in the array. So double nested for loop is always going to be n squared. Basic complexity would be n just because we're storing a array for the result that is at least going to be it's going to be somewhat smaller than n. It's because it's a subset, right? It has to be smaller, but in this case you would simplify that constant down to just n. Right, but the optimal way to solve this problem is to use a strategy called monotonic stack, right? And so I know it has a pretty complicated name, but it actually is a pretty simple strategy. You want to use monotonic stack when the goal of the problem is to find the next element in an array that satisfies some constraint. In this case, the constraint is that the element that we're looking at is greater than the element previous to it. So basically, you just iterate over the input list, and you would use a stack to keep track of the last element that didn't satisfy the constraint. And then as you're iterating over the input array, look at the top of that stack to see if the element that you're currently looking at satisfies that constraint. In this case, is if it's greater than the element that's at the top of the stack, right? Because stacks basically are a first in, last out array, right, or a list in some sense, where you're basically stacking things on top of the previous elements. So the first one that you put is going to be at the bottom, then you put something on top of that, put something on top of that, put something on top of that, and then the way you access it would be to take elements off the top of the stack, right, until you get to the bottom. So that's why it's called the stack. And so the steps to solve this first one, right, is just to iterate over nums2, right? And then you want to check your stack, right? So if your stack has any elements, right, in the first iteration it won't, right? But if your stack has any elements and the element that you're currently looking at in nums is greater than the element at the top of the stack, then you know that the element that you're currently looking at, num, is the next greater element to the ones at the top of the stack, right? Because we're iterating over, we're always going to be looking at the previous element that we just checked. Right, and so once you iterate over that, and once you do that, right, if there's anything left in the stack after you kind of do this popping and kind of find the next greater element, you iterate over that whole stack, and you basically use a dictionary to keep track of all of the greater values of that element, right? But if there are still elements in the stack after we've already tried to pop, then we know that we have not found that next greater element yet, so we would just set it to -1. And at the end, we would just do the same thing I said before, basically use all of the values that are in nums1 as the keys, and then return a array of the values of those keys, right? Because nums1 is a subset of nums2. We're going to have all the values that are in nums2 in this dictionary. We just want to return a subset of them, right? So in this case, to kind of give you a smaller walkthrough, right, with this input that we're given in our example, right? First off, we would start with 1, right? As we're iterating over this nums2 array, right? Our stack is empty, right? So then we would just kind of place 1 onto our stack here, and then we would also I didn't actually have this in here, right? So you would actually, the third step actually here is to append the num to the stack, right? or it's append or push in this case, if you've heard this terminology, right? Pushing and popping. Pushing basically means pushing an element down onto the top of the stack, and popping is taking an element off the top of the stack. Right, so those words are somewhat interchangeable because append always puts an element onto the end of the array. So getting back to our example, right, we're going through our first iteration with nums1. We did not find the element greater because our stack is empty, so we would have push num1 onto the stack and then iterate over the stack because we still have not found a next greater element for a 1. We would put 1 right here and have its value be set to -1. The next thing we would do is go to 3, right? Our stack does have something in it this time, and 3 is greater than the element at the top of the stack, which is 1. So we would we would pop this off the stack, right? So we would remove this off the stack and then change the value that for our dictionary, right, at this key 1, right, because it pops up the stack. So this is 1. So dictionary at 1 is equal to num. So we would now change this instead of -1. Next greater element of it is 3, right? And then we would move over to 4, right, to show that, and then we would append 3 onto our stack rather after that. Append 3 onto our stack, and then iterate over the stack again. So we would set 3 to be equal to -1 in this case, and then continue forward. So now we're looking at 4, and now 4 is greater than 3, so we would pop 3 off the stack, and then change this value from -1 to be 4, and then we would push 4 onto the stack. And then from there, we would do the same thing, look at 2. 2 is not greater than, so we would push 2 onto the stack, and then set 4 to be -1 down here. Do the same thing for 2. So we would, if I can drag this down here, put 2 down here with a -1 as well. Right, and then so once we have iterated over the whole array and we found all our possible next greater elements, we would then create our result array with all of the values for the keys that are in nums2. So the keys that are in nums1 rather, right? So nums1 has 4, 1, and 2. So we would just say for 4, the next greater element is -1. Here, let's make this a little bit bigger. So for 4, refer to our dictionary, next greater element, we didn't find one, so it's -1. For 1, we did find one, it's 3. And then for 2, we did not find one as well, it would be -1. And so in this case, that would be our result array, which, as you can see, coming back to this example, is the proper output, right? So we're going to code this solution up here, real simple. So the first thing we need to do is to create the dictionary that we're going to use. So we're just going to use DI in this case. We're going to iterate over nums. So while stack and num is greater than the stack at -1, we're going to do di at stack.pop is equal to num. Then after that, we would append onto our stack. And then for all the values in the stack, di at x is equal to -1 because we have not found an element greater. And then we just want to return, do a little list in my list interpolation here. So do d of x for x in nums1. That's basically all we have to do. Pretty simple solution, right? So basically iterating over the list like we talked about before, looking to see if we have a value on our stack, and if so, is there an element that we're currently at greater than the element at the top of that stack? If so, that is a next greater element. And we would just put that into our dictionary, and at the end, we're looking at all of the numbers that are in that subset and getting the value that we set for it, right? That next greater element that we set for it. So I'm gonna run this. Oh, whoops, needs to be nums2. Yeah, And I believe that should be it. Oh. We have initialized our stack as well. All right, so as you can see here, I made some slight errors, but pretty simple solution. Basically, initializing your dictionary, initialize your stack, iterate over nums2, check the stack. If we find that next greater element, keep popping until that is not the case, and then we will append the current number onto the stack, and then all the ones that are still in the stack where we haven't found the next greater element, set those to be -1 on our dictionary. Iterate over all of the numbers in nums1 using those numbers as the keys in our dictionary and returning all the values, which would be the next greater element. So now we're going to move over to next greater element 2. All right, so next greater element 2 adds a little bit of complexity into this, but it's still using that same monotonic stack strategy. So given a circular integer array nums, return the next greater element for every element in nums, right? So circular array basically means that the list kind of loops back in on itself, right? So the next element after 2 is 1, but the next element after 1 would be 1 because we would loop back behind it, right? That's what they mean when they say a circular array. Now, interesting thing with this that there still is a pretty simple brute force solution, right? We would basically just do that double nested for loop again, but in this case we would actually initialize a pointer at the index right after where we're kind of doing our top level loop, and then kind of keep iterating until we get to that same index again using like a modulus operator. Where we basically just get the remainder that exists after dividing the element or the index that we're currently at by the length of the array, right? That basically kind of keeps us within the bounds of the array. But the optimal way to solve this is, again, using monotonic stack, right? So you now hit the next greater element 2. All right, I'm going to go through the steps here. So same thing, like I said, we iterate over a range of I to the length of nums, right? And again, we're checking our stack to see, if the number that we're currently looking at is greater than the number that's at the top of the stack. Now, in this case, we're not putting the value on the stack, we're putting the index on the stack. And this is important to remember because we're using the indexes in this case because it's circular. We're going to need to know, what index that we're currently at because the result array is going to be the same length as nums, right? There's not using a subset this time. So after we check our stack, and see that, we have a value there, we would do the same thing, pop, right? This is restoring the index. We would just say that the result array at the index that was on the top of the stack is equal to the number that we're currently looking at I, right? And then after that, we would append the number at I onto the top of our stack, right? Or we would append, actually not nums at I, but we would append I onto our stack, append the index, and then move forward. Right now, what this does is this gets all of the elements that are greater in a forward pass sense, right? So all the greater elements that are in front of it. But this first loop does not take care of the circular nature of this problem. So what we do for that is we would do just another for loop after this initial for loop, where that basically allows us to kind of now check behind the elements that are in the stack, right? So we would iterate over nums again, and then check to see if the number at that we're currently looking at is greater than the number at the top of the stack. If so, then we do that same thing, just pop that index off the stack, and then say that the number that we're currently looking at is its next greater element. All right, so we're going to run through this again with a little example. So we would start off with number 1, right? Our stack is empty, so we would just append 0 onto our stack, or we would append the index on top of the stack. We go to the next one, right? We're at 2. And we would see that 2, or the index 1 rather, so the value at index 1 is 2. The value at that index is greater than the value at the index that's at the top of the stack, right? So 2 is greater than 1. So we would now say that in our result array, right, the value that for index 0, right, the greater element is 2. Right? So we would take 2 off the stack, and at the end we would append 1 onto it, and then go again, right, where we're looking at 2, right, index 2. The value at index 2 is not greater than the value at index 1, so we would append 2 on top of our stack. Right, and so this is how we would be looking at this point, right? So now we're going to iterate over nums again. right? To kind of check behind these two elements to see if there are greater elements before it. Again, the circular nature of this problem. So now we're going to read over nums again. Look at 1. Right? Our stack does have something in it, but the value at this index is not greater than the value at number 2, right? They're the same. So we would go again, look at 2, say, okay, yes, the value at index 1, right, which is 2, is greater than the value at index 2, which is 1. Right? So that means that we would plop this off the stack, and then at the 2 index, we would place the number that is greater than it, which is 2. Right? And then do the same thing again here, where we would look at 1, not the same, does not satisfy the constraint, so we would just end. And this would be our resulting array, right? As you can see, this is right, because the next greater element of this one is 2. 2 does not have an element greater than it in the array, so it's going to stay at -1. And then for this last one in the array, due to the circular nature, we would then loop back and see that its next greater element is 2 also, right? So we would hit the end, go back to the front. This is the same as it, and then we would go to number 2 and see, okay, this is greater than, so we would say that the next greater element at this index 2 is the number 2. And as you can see, when we come back here, right, that is the result in our example. So now we're going to code this up. First off, starting with our stack, with initializing our stack, and then we are going to initialize our result array, which is going to be a array of -1, -1s for all the length of nums. Now we're going to iterate over the range of the length of nums. And then now, so this is the kind of the simple monotonic stack for this forward pass, right? Once we find an element that's greater than it, we're gonna pop that index off the stack, and then set its next greater element to be the that we're currently looking at, right? With I, append that index onto the stack, and now for the second for loop, we're gonna take care of this kind of backward pass, take care of the circular nature of this array. So we're going to do the same thing. So while stack and num is greater than num set stack -1. Result at stack.pop is equal to num. At the end, we can just return our result array. And this should work. All right, got those accepted. And as you can see, this is the optimal solution. Beats about 98% of all the other submissions. So yeah, that's a quick introduction into monotonic stack. Hope you all enjoyed this video. Have a great rest of your day.